This video will be on angles of rotation and radian measure. Now we know from geometry that an angle is the union of two rays, these two, with a common endpoint, right here. The common endpoint is the vertex of the angle, and the rays are the sides of the angle. We can extend the way we think about an angle if we consider an angle as a turning motion. Imagine that the two rays are fastened by a pin at the vertex. One ray is kept fixed as a reference, called the initial side of the angle, and the other ray, the terminal side, is allowed to rotate to form an angle. Angles formed in this way are referred to as rotation angles. One of the major differences between angles as you previously experienced them and rotation angles is that rotation angles are usually not just placed anywhere. Rotation angles are placed in the coordinate plane. So the vertex is at the origin and the initial side lies on the positive side of the x-axis. This is referred to as standard position. The ray that forms the terminal side is rotated around the origin, and this results in various different angles. To indicate the direction of rotation, an angle is positive when the location of the terminal side results from a counterclockwise rotation. Meanwhile, an angle is negative when the location of the terminal side results from a clockwise rotation. Thus, these two angles are both 45 degrees, but this one's positive 45 and this one is negative 45. Additionally, an angle is referred to as the quadrant in which its terminal side lies. Here, since it's in quadrant 1, this is a first quadrant angle. Since this is in quadrant 4, it's a fourth quadrant angle. Finally, an angle in standard position with its terminal side coinciding with one of the axes, here, 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 or here, is called a quadrantal angle because it does not lie in any particular quadrant. Here we see an example of coterminal angles which are in standard position and share the same terminal side. The 130 degree angle and the negative 230 degree angle are coterminal. Further, angles are also coterminal when they share terminal sides as a result of complete rotations. For example, a 20 degree angle and a 380 degree angle in standard position are coterminal. If you were asked to find a coterminal angle of, say, 130 degrees, you would simply use the formula of 130 degrees, or a different angle measure, plus or minus 360 degrees times a constant, k, with this constant being a whole number. Here are two example problems of finding coterminal angles. If you wanted to find a positive coterminal angle of 60 degrees, you would do 60 plus 360, which would get you 420 degrees. If you wanted to do a negative one, say you wanted to do two rotations, you would do 60 minus 360, with the 360 being multiplied by 2, which would get you negative 660 degrees. For negative 180, if you wanted to find a positive one, you would do negative 88 degrees plus 360, which would get you 272. And if you wanted to do two rotations in the negative direction, if you want to find a coterminal angle there, you would do negative 88 degrees minus 360 times 2, which would get you negative 808 degrees. Up until this point in the video, we have only measured angles in terms of degrees. However, if we use radian measure, it allows us to treat trigonometric functions and other angle-based functions as functions with domains of real numbers, distances, rather than angles. So what is a radian? A radian is the central angle that subtends or goes up to an arc length equivalent to one radius. One radian measure is the same for all circles regardless of size. If you mark out the length of one radius along the circle, 6.28 radius, or 2 pi, would fit along the entire circumference, and this makes sense because circumference equals 2 pi times r, and r is the radius. Now, one full circle in terms of degrees is 360 degrees, right here. But what would it be in radians? The answer is found in the previously mentioned circumference formula, 2 pi r. And since it's 2 pi r, there are exactly 2 pi radii that fit along the circumference of any circle. So then there is exactly 2 pi radians in one full circle, or one full 360 degrees. This means there is pi radians and 180 degrees of a circle. Now, if we wanted to convert from degrees to radians or radians to degrees, we can use the previously stated relationship of pi radians equaling 180 degrees to get that 1 degrees equals pi radians over 180 degrees, and 1 radian equals 180 degrees over pi radians. Here are a couple practice problems with converting from degrees to radians and radians to degrees. First, with 32 degrees, we do 32 degrees times pi over 180 degrees, which will get us 8 pi over 45. If we wanted to do negative 40 degrees, we do negative 40 times pi over 180, which would get us negative 2 pi over 9. And then for 7 pi over 8 radians, converting that to degrees, we would multiply that by 180 over pi radians, which would get us 157.5 degrees. And if we wanted to convert negative 13 pi over 10 radians, we would multiply it once again by 180 over pi radians, which would get us negative 234 degrees. And that is all you need to know about angles of rotation and radian measure.